Welcome to qnawire.
In this problem, we have to read this graph in order to find the answers. In part A, we want to identify the regions of kinetic and static friction. Now, to do this, first we need to think about the characteristics of these two types of friction. In static friction, we know that the object is not able to move, and that is because when we push, friction is going to respond with the same amount of force. So in static, we push with some force, and friction responds with the same amount of force, so it cancels out. They have to have the same magnitude. In this graph, when we look at this line, we see that when we apply a force of push, 25 newtons, friction provides 25 newtons in the opposite direction. Therefore, we see that throughout this line, force of friction matches the force of push. So static friction is in this region until here. Now over here, we have a plateau. That is where kinetic friction takes place. Because when we push, we are able to move the object. So that means that the forces don't cancel out. We have a smaller response from the force of friction. So we identify that this is kinetic friction. So from 0 to 75 newtons, we have static. That is the first answer. And the second one is that from 75 until infinity, we have kinetic friction. Great. Now let's move on to part B. In part B, we want to find the actual coefficients of friction, both the static and kinetic one. Now, let's remember the equations that we have for each of them. The force of static friction is equal to the coefficient of static friction times the normal force, which is equal to the weight of the object. But this force is going to be the maximum force that the static friction provides, because we just said that static friction matches the force we apply until it gets to this point, 75 newtons. So that maximum force is going to be those 75 newtons, coefficient of static friction, and the weight. And we are told the weight of the block. We're told it weighs 135 newtons. So that means that the coefficient is going to be equal to 75 divided by 135. And that gives us roughly 0.56. This is a unitless coefficient, so we don't write any units. Then we have kinetic friction, which has a very similar structure, but this time we have a different coefficient. So this is going to be this force, this 50 newtons over here, over the weight, and that is 135. And this gives us roughly 0.37. And those are our answers for part B. Now in part C, we have kind of already answered part C. We want to be able to tell why this graph first increases and then plateaus. Well, it increases because static friction matches the force we apply. And the consequence of that is that there is no net force because, as we just said, the forces keep canceling out. So the region where we have the slope, we have static friction. And now we know that this plateaus because friction provides a constant amount of force so that there can be some acceleration. And so if friction no longer matches the force of push, then we have some net force. That is why we can say that net force is no longer zero. Although we have to note that we could move at a constant velocity if we provide the same amount of force as the force of kinetic friction. But the point is that the block is able to move because the forces no longer cancel out as they did previously. Now let's move on to part D. In part D, we are told that we add another block on top of the one we already had. And we want to find the forces and the new coefficients. But there are no new coefficients because we have to remember that both the coefficient of kinetic friction and the coefficient of static friction belong to the materials of the surface and the block. They don't depend on the mass or the weight that is put on the block. Now, if we were to, let's say, grab a block made out of soap, then we would change this because we would be changing the material. But since we're just adding another block, these two remain the same. But the forces do change because remember that they are dependent on the weight. So let's calculate them. First, we're going to have force of static friction. That is the coefficient of static friction times 2 times the weight, because we have another block that also weighs 135 newtons. So we have our coefficient, which is 0.56, as we found, 2 times the weight, and that gives us around 150 newtons. Then we have kinetic friction. And we don't simply have to find these, we also have to graph them. We are going to use them to graph how the new model would look like with 2 blocks. So let's do that now. Here we have our graph, and we have the point where static friction will be its maximum. So that is 150. That means when we exert 150 newtons, force of friction is going to respond with those 150 newtons. So let's draw that line. We go from 0 up to 150 newtons. Great. Now we know that at that point, we're going to go down and plateau at 100 newtons as we calculated. So let's represent that. And here we have it. We have a portion of static friction and then 100 newtons of constant kinetic friction. And that is our answer for part D.